Build friction calculation. Let's say we're trying to hold a 1,000-pound object by using a rope. So how much force we have to apply to do that just to using that friction? So we're trying to find out that value for P to hold these 1,000 pounds. The formula for belt friction is the large tension. So in this side, so that's the tension has the large tension side, and this is the small tension side. So we're just trying to keep this object up. We're not pulling up or down or anything like that, just to stay as it is. Now, belt or rope or any flexible material, they can't really push. They only can have tension. They only can have pull. So the formula for this is the large tension is equal to the small side tension times the E of mu beta. As you know, mu is the friction coefficient. So in this case, we're trying to keep this 1,000 pounds static just by applying P. So we're trying to find out that TS, which is P in this scenario. Assume that the friction coefficient between the rope and the drum, this fixed drum or cylinder, is 0.2 times the beta is called the angle of wrap. So how much it's wrapping? Let's say it is wrapping at half turn, which is 180 degree, but in this formula you can't use 180 degree. You have to use the absolute value in radians. So pi radian, which is 3.14. So the beta value given here is 180 degree, which is pi radian, which is 3.14, like that. So then you can calculate the small side tension. I found that 533 pound. So this is the value for P if you use half turn of this rope. I also did calculate it if you say do it for like 1.5 turns. So instead of wrapping like this, let's say you are wrapping like this, that will require less force. So I found that if you do 1.5 turn, that force is you just only have to apply 152 pounds. If you do, say, for example, 4.5 turns, then only 3.5 pounds. And then if you do, say, 6.5 times, then you only have to apply 0.28 pounds, few ounces. Now, 6.5 turn is one full turn is 2 pi times 6 plus half turn. So total actually 13 pi. So if you plug those 13 pi here and 0.2, you're going to get this.